This next unit we're going to be starting is statistics, and then I have the notes up here, and I'll explain as I go along what the notes show. Statistics is simply collecting, organizing, and interpreting data. We can collect statistics in many different ways. One way to collect statistics or data is to use a survey, which is a method of collecting information. Now, a survey could be online. It could be someone standing outside of a store asking you something. It could be through the mail. When you get older and you get your own phone number. At night, I receive all kinds of calls. We're taking a survey on who you think should be president. Would you take 5 minutes to take this survey? So a survey is a way of collecting data. The population is the group that's being studied. So if I took a survey of NTMS students about their favorite color, then my population would be NTMS students. A sample is part of the population surveyed. Now, a reason why we use a sample instead of all the population is because it saves time and money if we use a sample. And if our sample is good enough, it usually reflects the population. So for each survey topic, determine which set represents a population and which represents a sample of the population. Our survey topic is dress code changes. Set A, we have the students in a middle school, and set B, we have the 7th graders. Now, the population is all of the students in the school. The sample is only the 7th graders in the middle school. So the population is everybody. A sample is only part of everybody. Favorite flavors of ice cream. The population would be the residents of the town, the whole town. A sample might be only the customers at an ice cream shop in the town. So a sample here is part of that population. Just like up here, this sample was part of that population. Logan wants to survey students in his school about their favorite and least favorite ice cream flavors. Describe a possible sample Logan could survey instead of surveying the entire school. Now, if you surveyed the entire school, it could take him a long time to get every student. So one way is he could survey every 10th student who enters a school building in the morning. It would be a random sample, so it wouldn't be only the students in his class, which is a better sample. He could do it during lunch. He could do it during study halls. So there's many ways to give a sample a survey. We can use results of surveys or past actions to predict the actions of a larger group. The ratios of the responses of a good sample are often the same as the ratios of the responses of the population. This is a kind of a fancy way of saying if we get a good enough sample, we can predict what's going to happen with a large group. For example, the U.S. Census is done every 10 years. Okay? Not everyone returns the census, but those that do return the census, their information is used to help determine information about the population in each city. So the government sends out this packet. Your parents may have filled it out. They may not have. It's not mandatory. You don't have to do it. And what it asks is how many people live in your house, the age of the people. Income, I'm not sure. I don't remember if it asked about income or not. The number of children. So they use that information to kind of gauge how old or young a city is, what the population is. Now, not everybody returns it, so the people that do kind of become the sample of the population. So the ways that we use these predictions, a survey found that 7 out of 10 students have a Twitter account. So the probability that someone has an account is 7 out of 10. Now, this is what I know. I know there's 7 out of 10 students that have an account. I can use that to predict out of 250 students how many would have an account. So I use a proportion. This is what I know, 7 out of 10. This is what I want to know, out of how many 250 would be. So I'd solve that by cross multiplying 7 times 250 and then divide by 10, the number that's with x. That gives me 175 students. So a good estimate would be 175 students out of 250 would have a Twitter account. Example 2, a survey found that 85% of people use emoticons in their instant messengers. Predict how many of the 2,450 students at Washington Middle use emoticons. So again, 85 out of 100, that's 85% written as a fraction, but I want to know out of 2,450. So again, I multiply 85 times 2,450, then divide by the number that's with x. So about 2,083 students. Now the answer you get is 2,082.5, but that's not a number we can have because you can't take half a person, so we round that to 2,083. In the next part, there's a table here, so we can use this information in the table. So the first question says, what is the probability of choosing a career in public service? Here's public service, there's 6. And I add all these up, that's 50. So 6 out of 50 would possibly choose public service. Number 2, education. I look in the chart or the table, here's 14. So again, it's 14 out of 50. Now I'm going to use that to predict how many there would be out of, for question 3, 400. So here's education field, there's 14 out of 50, that's what I know from the chart. I want to know out of 400 though. So again, I solve that proportion by cross multiplying 14 times 400, then divide by the number with x, which is 50. Number 4, I'm looking at the medical field, so I go up in the table, and if you notice in the medical field, there's 11 right there, 11 out of 50, so that's where this comes from right here. I use that, 11 times 500, divide that by 50, 110 students. Another way the information can be presented is in a graph. So you notice we have a circle graph here. And we're looking at the number of people, their pie preferences out of 3,500 citizens. So question 5, I'm looking at those that like apple pie. So here's my apple pie. It's 36%, remember? 36 is out of 100, that's percent. I set up a proportion. So I multiply 36 times 3,500, divide by the number with x, 100. So about 1,260 people would prefer apple pie. So we're using ratios and charts and tables and graphs. All of these things that we talked about here are all the same idea. This is a graph. We used a table. We used a word problem. They all can be used to predict outcomes.